The following example illustrates the different thermal stabilities of different silicone fluids. WACKER AKC 12500 is a specially stabilized silicone fluid with a viscosity of 12,500 mPa/s. It is highly heat resistant. WACKER AK 12500, by contrast, is a typical silicone fluid. Its viscosity is the same, but it has not been stabilized. The heat resistance of special silicone fluids is evidenced by their constant viscosity, even when exposed to very high temperatures for long periods of time. The two silicone fluids were first heated to 200 degrees Celsius for 3 days. After this time, the viscosity has not changed for either fluid. After 10 days at 200 degrees Celsius, the consistency of the AKC product was unchanged, while the viscosity of the AK product had noticeably increased. The rise in viscosity is caused by polymer chains cross-linking with each other in response to oxidation at high temperatures. Silicone fluids consist of polymer chains. When the product is heated to temperatures of over 170 degrees Celsius, many of these chains are damaged by oxygen molecules. The damaged polymers then react at precisely these points to produce a three-dimensional network. The first sign of this is an increase in viscosity. When degradation is complete, a gel or rubbery material is produced. The use of special stabilizers, as is the case in WACKER AKC fluids, inhibits or at least slows this cross-linking process dramatically. This is why the viscosity of the AKC fluid remains unchanged even after 11 days. AK fluid, on the other hand, is not stabilized, and cross-linking has progressed to produce a gel-like consistency. After 12 days at 200 degrees Celsius, the viscosity of the AKC silicone fluid is still unchanged. The AK fluid, however, has gelled and no longer flows. This makes it clear that the AKC-grade silicone fluids do not gel, even when used at temperatures of 200 degrees Celsius or for periods of several thousand hours.